we discuss a problem on finding the domain of a function which involves GIF, greatest integer function. This question has appeared in JEE main examination held on 20th July 2021 in the morning shift. The question is on the domain of a function which involves the bracket function, that is the greatest integer function. The example is, let bracket x denote the greatest integer less than or equal to x, where x is a real number. If the domain of the real valued function f of x is equal to under the square root of mod of bracket x minus 2 by under the square root only mod of bracket x minus 3 is open interval minus infinity to a union semi closed interval BC closed at B end, open at C end, union semi closed interval 4 to infinity closed at 4 end, where A less than B less than C. Then we have to find the value of A plus B plus C. The four options are given to us. Let us discuss this problem. Solution. We have, for every x belongs to R, bracket x is the greatest integer less than or equal to x. Further, we know that x is equal to bracket x plus fractional part of x, where fractional part of x, this curly bracket x stands for the fractional part of x, and the fractional part of x lies between 0 and 1, and it will take the value 0 also. That is 0 less than or equal to the fractional part of x less than 1. We are given with the function fx is equal to under the square root of mod of bracket x minus 2 by under the square root only mod of bracket x minus 3. Let us put bracket x as m. Let m is equal to bracket x. Then fx will be equal to under the square root of mod m minus 2 by mod m minus 3 under the square root. It is defined. When this is defined, this function is defined, if mod of m minus 2 greater than or equal to 0, because it is in the numerator and under the square root, and mod of m minus 3 greater than 0, because it is under the square root and it cannot take the value 0 because division by 0 is undefined. Or mod of m minus 2 is less than or equal to 0. When it is less than or equal to 0, the denominator must be less than 0. Greater than or equal, less than or equal to 0, and less than 0 will bring you greater than or equal to 0. So mod of m minus 2 less than or equal to 0 and mod of m minus 3 less than 0. This will imply mod of m greater than or equal to 2 and mod of m greater than 3, or mod of m less than or equal to 2 and mod of m less than 3. This implies mod of m greater than or equal to 2 and mod of m greater than 3. These put together will be, if you can see on the real numbered line also, mod of m greater than 3. And these two, mod of m less than or equal to 2 and mod of m less than or equal to 3, and if you take it, that will be mod of m less than or equal to 2. And this is the first statement or the second statement. Let's look for further analysis in the next slide. We have mod m greater than 3 or mod m less than or equal to 2. If mod m greater than 3, m belongs to minus infinity to minus 3, open interval, union, open interval 3 to infinity. So you have to convince yourself, and you may be knowing because you are using this such inequalities and the intervals involved in your study. Mod m greater than 3 will imply m belongs to the open interval minus infinity to minus 3 union open interval 3 to infinity. Mod m less than or equal to 2 will imply m belongs to the closed and bounded interval minus 2 to plus 2. And this is the first statement or the second statement. Because it is a or statement, it will be union again. Thus m belongs to minus infinity to minus 3 open interval union open interval 3 to infinity union closed and bounded interval minus 2 to plus 2. We have written in this way. Therefore, m means bracket x. Therefore, bracket x belongs to this union. Now we will consider three cases. First case for this, second case, third case. So, case 1. Bracket x belongs to minus infinity to minus 3 open interval. That means bracket x will be less than minus 3. When bracket x less than minus 3, because bracket x is an integer, bracket x must be less than or equal to the next integer to the left of minus 3, that is minus 4. Because bracket x is an integer and bracket x less than minus 3, that will imply bracket x less than or equal to minus 4. What is bracket x? Bracket x is x minus fractional part of x less than or equal to minus 4. So send that fractional part to the other side. This will imply x will be less than or equal to minus 4 plus fractional part of x, where fractional part of x lies between 0 and 1 and fractional part of x also takes the value 0. That is 0 less than or equal to fractional part of x less than 1. So this can take the value up to 1 but not 1. So therefore this will be x less than minus 3. Note down x less than minus 3 because it is not taking the value 1. So therefore bracket x belongs to minus infinity to minus 3 open interval implies x belongs to the open interval minus infinity to minus 3. We consider the second case. The second case is bracket x belongs to closed and bounded interval minus 2 to plus 2. This implies minus 2 less than or equal to bracket x less than or equal to 2. Bracket x is equal to x minus fractional part of x. So add fractional part of x throughout. Then you will get minus 2 plus fractional part of x is less than or equal to x is less than or equal to 2 plus fractional part of x. Fractional part of x 0 less than or equal to fractional part of x less than 1. So minus 2 will be definitely be less than or equal to minus 2 plus x. Minus 2 plus less than or equal to minus 2 plus fractional part of x, because fractional part of x takes the minimum value 0 including 0. So therefore less than or equal to. And 2 plus fractional part of x, fractional part of x at the most takes 1 but not equal to 1, therefore it is less than 3. Therefore x lies between minus 2 to 3 open semi closed interval and closed at minus 2 end. This will imply minus 2 less than or equal to x less than 3. This will imply x belongs to the semi-closed interval minus 2 to 3 where it is closed at minus 2 end. So therefore bracket x belongs to minus 2 to plus 2 will imply x belongs to minus 2 to 3 semi-closed interval closed at minus 2 end. Take the third case. Bracket x belongs to 3 to infinity. This implies bracket x greater than 3. Again, we use the fact that since bracket x is an integer, bracket x greater than 3 means bracket x will, will start taking the values from integer 4 onwards. That is, bracket x is greater than or equal to 4. This happens because bracket x is an integer. And bracket x means x minus fractional part of x greater than or equal to 4. So that will imply x greater than or equal to 4 plus fractional part of x, where 0 less than or equal to fractional part of x less than 1. So this will imply x greater than or equal to 4 because the, the because bracket x is less than 1. It's not taking equal to 1. So therefore, but greater than or equal to 0. Therefore, x is greater than or equal to 4 only, it will tell you. So therefore, bracket x belongs to 3 to infinity open interval implies x belongs to the semi-closed interval 4 to infinity closed at 4 end. 4 end. Okay. So now we have discussed bracket x belongs to the union of the three intervals will imply x belongs to open interval minus infinity to minus 3 union semi-closed interval minus 2 to 3 closed at minus 2 and semi-closed interval 4 to infinity closed at 4 end. So from mod x we have traveled to x. So therefore, thus fx is that given function is defined for all x belongs to this union of intervals. Open interval minus infinity to minus 3 union closed minus 2 to 3 open union closed 4 to infinity open. This is defined for all these things means obviously this will be the domain. So therefore the domain of fx is this one. But you are given that the domain of this is open interval minus infinity to a union semi-closed interval b to c closed at b end union semi-closed interval 4 to infinity closed at 4 end where a less than b less than c. Now we see compare with our answer. A is minus 3, b is minus 2, c is 3, and obviously minus 3 less than minus 2 less than 3. So the conditions are satisfied. Therefore, A is equal to minus 3, B is equal to minus 2, C is equal to 3. And note down, this satisfies the inequalities A less than B less than C. So therefore, we have found the domain of that and we have got the values of A, B, C required to find A plus B plus C. A plus B plus C is equal to minus 3 plus minus 2 plus 3 and plus 3 minus 3 cancels and the answer is minus 2. The options are, the four options are here and our answer minus 2 is against the option 2. So our final answer is option 2. This comes to the end of the discussion of this solution and certainly it is a very interesting example and, and it is a very good example and examples of this type can occur quite frequently in due course also. I hope that you have understood the solution and go on working out some more problems of this type involving bracket function, that is greatest integer function, from a standard textbook. I wish you good luck. Thank you.